Hello everybody, and welcome back. In this lesson, we're going to be building a steam boiler. Wait, but you may think that we already built a steam boiler. That's true. However, today we're going to be building a more advanced steam boiler. Get this. Wow. We have a cold machine, and we have a path that the heat travels through. And heat and the steam travels through. So, yeah. That's what we're going to be building. However, don't worry, we're not doing all of this today. We're going to start with this. Now let's take a look and see if you can guess what part of this is this. Okay. Now, let's remember your guesses because you're going to be checking them very soon. There will be clues leading up to the review too, so yeah. Okay. Import BPR. Import math. Import math-utils. Import vector and Euler. And we don't import math-utils, we from math-utils we import vector and Euler so we can change location dimensions, the rotation, and all that good stuff. Okay, next we're going to add something called global parameters. So parameters can use basically anywhere inside this code. Now we're going to use a lot of them. So I'm just going to paste them in and you can pause the video and copy them to be able to get them. So here it is. Now if you look closely at them, you might get a hint at what we're using. No, not what the parts are, not what we're using. I mean, we can still see what we're using, but what it meant was what are the parts. Now we're only actually I'm gonna be only revealing two of the parts today, but you can guess what they are. Alright. Now, next thing we're going to do is we're actually going to be creating a class. We're going to be using object-oriented coding. So, we'll be using classes and methods and everything. So let's create a fancy little thing here so our code looks cooler. Let's start class geometry because we don't want to type out all geometry. Now we're going to create a method called static method. It's gonna be clear scene. A static method is a method that you can use without needing to create another object. So you don't need to create an object to clear the scene. BPY object dot select object dot select action is select BPY dot ops dot object dot ops dot object dot delete, and there you go. Okay, now for the next two static methods, we're going to be creating something that will allow us to build certain things. So it'll be very useful. Static method box name size location, notation, name, size, location, and notation on X, Y, Z axes. And then, well, if you looked at my other videos, you know how to add it. So if you go to ops.mesh.primitive cube add, the size is 2, location is the parameter for location, rotation. Okay. Now let's create a variable called O, and what this variable is, it's basically just going to be the object, so this might be before the context so active object. And the reason we want this is because we can just write like O.name is name to get the name, this thing. Whereas otherwise it writes like before the context the active object dot name, which will be way longer. And same thing for here, dimensions. We don't want the whole thing is vector, and then it's the size parameter we insert, and then we just return the O. So next thing we're going to do is we're going to create a method that can create cylinder. So it's going to be pretty similar, not exactly the same, but there's going to be a lot of similarities. So size we actually split into radius and depth. Location and rotation are still the same, and obviously we replace the cube with cylinder, and size is split into radius and depth. But the rest are still the same. So is O, and then over here dimensions, we want the diameter to get the dimensions, so it's radius times 2, radius times 2, depth. Then yeah, we return it. Okay, we're done with our geometry class, and we can use these methods now to help us build our other things. Okay, next we're gonna start building 2 of the parts of this. We're gonna be building this small thing over here and these walls. And there are 2 different parts of it, and try to guess what they are and see if they match with what you guess. So let's call these component classes because they're components of the whole entire model. Class, okay, great, is what we're going to call this thing over here, because it's a grate and it's for coal. And the first method we're going to make is actually something called initiation method. So over here we define the center, its dimensions, stuff like that. So self.center is vector center. Self.length. So the center is the center of the parameter you put in here, but notice that we haven't put the thing in the parameter for the length. So how do we put it in? Well, we have global parameters over here, so we can just put them in for all of our dimensions. The slats is great. slats dot slat thickness is slat thickness. Slats are these things, the bars. And yep. And great slats is the number of slats, and then these are the widths and the heights, and then the slat thickness, which I already did because I forgot, and the height. Then we have the slat gap, which we just take the width minus the number of slats times the thickness, then divided by the number of slats to get the gap in between. Next, we're going to be making something called a property method. So we have a property, and this one is called top z. I actually don't need a self parameter, but I'm just going to add it so it makes more sense. Return self.center.z plus self.slat height divided by 2.0. So the center, the z is the center, right? Adding half of it will get the very top of the grate, and that'll be very important for later, and you'll see why. Okay. Next, we're going to wait. I put the property thing into the initiation. Okay. Now let's create a build method, and then self. Now, since the grate is a series of slats, we're going to need a for loop, and it's better if we put all the objects in a list. So that's what I'm doing here. For I in range self slats, local y is negative self width divided by 2.0 plus I times self.slat thickness plus self.slat gap. So the y for basically each of the slats. So we have the negative of the width. So the grate's width over here divided by 2. So get the midpoint. And then over here we have I times, in the parentheses, the thickness plus the gap. So you get this. We multiply that by I. So the number it's on, so if it's 1, we do it 1 of that. Adding to this, we get the local y value. Slat y is self.center.y plus local y. Slat x is self.center.x. Slat z is self.center.z. And slat is geometry.box. Remember, we're using this method. The name is the grate slat, and then I0 2D. That's the name. The size is just the self plus the perimeters. So that's slat height. And then what's it called? The location is just everything. Slat objects dot append slat. And we return the slat objects list to Beauty Bit. because it's a list of the other objects. We're done with the class, this thing, the grate. Now for a second one, and see if you guessed it right. This part, it's the furnace, because we put the coal underneath the grate, which will heat up. So here is the furnace, right? Makes sense? So yeah, let's make that class furnace. And obviously, we need the initiation with the self center. But we only need XY. That's because the Z, well, we'll put that in later and you'll see. Self.fx, self.fy, or it's the center. XY that we put in, that we define. Now self.fc is none for now. The depth is furnace depth, and I spelled furnace wrong. Self.width is grate width. Self.height is furnace height. Self.wall thickness is 0.1. Now we can go straight to the build because we don't need this, and you'll actually see what we put in the Z. Self grate top Z. So the Z coordinate for the very top. So the bottom Z of the furnace will be the top of the grate. But the top of the grate, the furnace, is going to be the bottom of the furnace plus the height to get the Z coordinate of the top, and then to get the middle, obviously, we average them out. Bottom Z plus top Z divided by 2.0. Well, you could do this multiple ways, but that's how I'd like to write it. Okay. Now, let's start with the walls. We're building the walls individually. The back wall first, and you'll notice its shape. It's kind of like a box. Yep, we're using it. Furnace back is what it's called because it's back of the furnace. Self dot wall thickness, self dot width, and self dot height. Self.fx minus self.depth divided by 2.0, self.fy, and center Z. So the x, so x is back and forth on this image, right? Because we actually tilted it over here. I think when you first open Blender, x is like that, but in this image it's back and forth. So you can see that it's actually behind so that's why we put minus self.depth to make sure that the x location is back there and it's not like in the middle of the furnace. Now let's copy this because we're going to be using this quite a lot. Okay, for now we're going to make the left. So this point. So the dimensions on this side, except it's not wall thickness, that's the first size parameter, it's the depth, and it's not pushed back, so actually self.fx is the perfect x, and actually we need to subtract self.width, half of self.width from this to get the good y position. And the right is more similar to the left than it is to the back, so I had to copy it again. Make sure to rename to right. Oh, I forgot to rename this. Furnace back. And my things are not aligned for some reason. Oh, yeah, okay. Because right is longer than left. Left, okay. Now, for the right, notice that this is a bit lower, right? Because if you look at this model, the the air and heat steam is going that way. So we're trying to replicate it over here. So self height versus divided by 2. Now, if you divide the self height by 2, the center is going to be at the top. So center also divides by 2, and then the width is plus this because, well, we don't want it to be on top of the left. And now furnace top is going to be actually, I'm going to continue using the left to copy and paste everything. Make sure to change furnace top. I misspelled furnace. So that over here, I keep spelling furnace wrong. And I also spelled furnace wrong here. Oh my god. Okay, it's right. And this is top. And the dimensions are width, height, well, not the same. Actually, yeah, not the same because the wall thickness is going to be the last going up and down because you can see it's like that and not as tall as these others. Okay, and now the width is actually perfect for this one, and we don't need to do an equation over here. We can just write top z, and then this is where we define self.fc is center z. Return, and then turn back, left, left, right, right, top, top, top Z, and that's the build. And that's it for today. We covered 2 of them. Next lesson, we're going to cover the last one and keep expanding on this. So, bye.